Hello and welcome everybody to today's lecture about protection and especially about overcurrent protection. And today's lecture is about time grading, safety margins, backup functions and sequential tripping. So let's start first with the time grading. So as you can see here, a typical system fault starts with a regime of normal current. Then we have a short circuit, and from that moment on we have heavy current flowing and the protection relays will pick up. After a certain time delay, while the short circuit current is flowing, they will trip and in the first step actuate the interposing contactors. These operate the circuit breaker, and the circuit breaker, after the time to clear the arc fault, will extinguish the arc fault and the whole fault is stopped. In the meantime, in the preceding overcurrent relay, which is graded with the overcurrent time T2, there is certain still a margin till it would reset. So this is a normal tripping behavior. And now let's see what is the importance of the safety margin, because we do not want that these two sequential trips interfere and intermingle with each other. So let's start again with the full picture. We have the fault, but there could be a variance in the pickup delay. There are old relays, mechanically operated, which may act slower, and then the whole procedure is postponed to the right side, to higher tripping times. Also, the retarding time, the grading time, may be increased, and that means that again the whole procedure lasts longer. And also the contactor and the arcing time may increase, and that will lead, as is indicated in the red circle, to an overlap with the intended tripping time of the upstream relay T2. So as we can see here, the T2 will start to trip its own preceding circuit breaker while the arc is being extinguished. Also, this can happen if the preceding relay is a little bit too quick, and even if the tripping time maybe is varied to the smaller time, so that we see there is a grading margin that is impaired by both time behavior of the downstream and the upstream relay. Now, there should be sufficient grading margin, and the formula is written here. So it is the difference between the pickup times, it is additionally the difference between the delay times, and we must always take into account the circuit breaker with its maximum arc clearing time. So how about the backup function, which is also an immanent feature of overcurrent time grading? Let's see here a typical network which consists of a source, a feeding bus bar and several lines, and we have a sensitive consumer on the medium line. Now a short circuit comes in, and the short circuit comes flowing from the source to the fault, and the relay will pick up after, example, 0.4 seconds. Now, what happens if for whatever reason the trip does not occur? That means after 0.4 seconds the current keeps on flowing until, and now you see what has been inserted, another upstream relay with a grading time of 0.8 seconds will pick up and interrupt the fault. So then the situation is cleared, the fault is cleared, but the disadvantage is that when this backup relay comes in, that we will lose the whole bus bar. The last section of today's lecture is about sequential tripping and the superposition of grading times. This may happen if we have parallel feeders. So as we can see here, the network is made up of two feeding lines for our sensitive consumer. That means, as was shown in a previous lecture, if one feeder fails, then the other one will sustain the electricity supply. Now let's see what happens in case of a remote fault. Let's suppose that we have a total fault current of 5 kiloamps coming in. It is split up into two more or less equal currents at the size of approximately 2.5 kiloamps. The overcurrent protection will pick up and will trip on the reverse side at 0.1 second. The current will flow on, and after 0.4 seconds total fault clearing time, the fault is completely tripped out and the system is safe again. Now we have a total time in this case of 0.4 seconds. The situation is different if we have a close-up fault, as is indicated here. If the close-up fault occurs, we have a split of the total current of 5 kiloamps into a big current which goes directly to the faulty place, and a smaller one that goes all the way around. And that may be, as indicated in this case, too small to start up any of those relays. So there is just one relay picking up, that's the upper one. It will trip after 0.4 seconds, and at that very moment the short circuit will come the other way around. That means now the relays that sense this increased current will pick up, and after one additional 0.1 second, the second relay will trip out. So the whole clearing time now is 0.5 seconds. So this may look as a small increase in triggering time, but when it comes to the backup function, we must take care that also the backup function will take of this possible situation. So that means the basic tripping time is not given by 0.4 seconds, but 0.5 seconds, plus the grading margin, as was indicated before. So this was today's lecture about time grading, safety margins, backup functions, and sequential tripping.